welcome to Roger's show. This is Roger's show now, and today we are going to be talking about the steps necessary to solve an object chasing problem. Now, you may be wondering, what is an object chasing problem, Roger? I have no idea. Well, it's really quite simple. It's a one-dimensional kinematics problem that requires us to find any of these three things: distance, time, and speed. Now, in these problems, you will need to find how long it takes for one object to reach another. Think of it as a cop car chasing a speeding criminal. Additionally, you may have to find how much distance was traveled or how fast each object was when they finally reached each other. In simpler versions, you could use two objects going at a constant velocity, but for my example, I wanted to choose one accelerating object and one at a constant velocity. These two objects are going to be a distance away from each other, or a certain amount of time away from each other. So you're going to have to either find that distance or use that time to figure out how long it takes for them to collide. A cop car watches a speeding criminal drive away from a crime scene. The speeding criminal gets a 10-second head start, and he is traveling at a constant velocity of 50 meters per second. The cop car starts his car and starts traveling at 2 meters per second squared. You need to find out how much time did it take the cop car to reach the speeder, how much distance did they both travel, and what was the speed of the cop car by the time it got to the speeder. So we'll start by taking into account what we know and what we need to know. So we'll make a table here. Hopefully the table will show up right here. And our initial velocity for the cop car is 0, for the speeder is 50. Our final velocity is unknown for the cop car, but for our speeder is 50. Our acceleration is 2 for the cop car and 0 for the speeder. The speeder is not accelerating, it's at a constant velocity. The distance it travels, we don't know for either one of them, but they are equal. And the time it takes, for the cop car, that's just t, but for the speeder, it's t plus 10, since that 10-second head start let it travel a lot further. Oh, looks like it's time for our designated candy break. Roger will be pausing the video and passing out all the candy soon, so just hang tight there. Here is where our best friend comes in. X equals initial velocity times t plus 0.5 a t squared. We'll create two separate equations, one for each car. You don't need the velocity section for the cop car or the acceleration section for the speeder, because they're both 0. So you're left with the following equations. For the cop car, it's x equals 1/2 times 2 times time squared, or just x equals time squared. For the speeder, it's x equals 50 times t plus 10. Remember that plus 10? Or that just comes out to x equals 50t plus 500. Now these x values are the same, so we can set them equal to each other, these equations. So we get 50t plus 500 equals t squared. Good so far? Now we'll set them all equal to 0. So t squared minus 50t minus 500 equals 0. And then we have to use the quadratic equation to find the correct time. So let me just crunch the numbers real quick, just in my mind, because I'm doing it in my mind. It definitely is not on the script. And if I look, nope, if I do the math in my head, then it comes out to 58.541 seconds, or negative 8.541 seconds. Now, since these guys are not traveling back in time, it's probably best to choose the positive answer in this equation. So 58.54 seconds. However, it's important to remember that this is the time it takes the cop, not the speeder, to do it. So you need to add plus 10 seconds for the speeder in order to get their actual time. And now we can really open the equation up. Now that we have a couple variables, we can really figure out everything we need to know. So, to find out how fast the cop car was going when it caught the speeder, just use the following equation. Velocity final equals velocity initial plus acceleration times time. So final velocity would be equal to 117.08 meters per second. And to find out how far the cop travels, we use the same equation from before. X equals 1/2 times acceleration times time squared, obviously without velocity, and then we end up with 3,426.93 meters. And that's about it. So how easy was that, huh?